morning. The last class we have discussed about the elasticity of demand and price elasticity, income elasticity, and cost elasticity of demand. In today's class, we discuss about the law of returns. Law of returns. What is the law of returns is? So, law of returns, if you look at here, the law of returns is nothing but it is going to give the behavior of the output with respect to the input. So the law of returns relates the behavior of output as a response to the changes in the inputs. So as we told, the inputs, we can take it as land, labor, capital, whatever it is. So if there is any change in the inputs, if there is any changes in the input, so how the output behavior, that law of returns is going to discuss about that output behavior with respect to the changes in the input. And also it explains the relationship between the various factors of production with the output quantity. So here the factors of production, so as we told that the factors of productions are nothing but we can take the land, labor, all this we can call it as factors of production. Capital, machines, all will be come under these factors of production, which can be produced into a commodity, or a product. Those are called as factors of production. And see, if you take an expansion in the scale of operation in a particular industry, if you have taken an example of industry, so increasing the inputs. So how, if you vary the input, how the output is going to be varied. So increasing the inputs proportionally and simultaneously. In such cases, there are three technical possibilities which can occur. One is if you are trying to increasing the inputs proportionally and simultaneously. You keep trying increasing the inputs. So the behavior of the output, which you can take into three aspects. One is law of increasing returns, and law of constant returns, and law of decreasing returns or diminishing returns. Okay. So total output may increase more than your proportionality. That is called as increasing returns. Means if you increase the input, if you are increasing the input variable or input parameters, the output also increase more than the proportionality, then it is called as law of increasing returns. And total output may increase proportionately, which is called as law of constant. Means how much ever you give, increase the input, the same equal amount of increase in the output. So that is what we can say law of constant returns. And total output may increase less than the proportionality, which is called as law of decreasing returns or diminishing returns. So if you look at this diagram, the law of increasing returns, law of returns to scale, we can say here, this is the graph which you can say, and here I have taken the input as the variable. So if there is a change in the input, so I'm trying to increase the input variable. So how this output behavior is, say for example, it is gone increasing this proportionally, but more than the changes in the inputs. So that is what we can say, this part you can say it is called a law of increasing returns. Whereas up to this point, say it is called as the constant. The output behavior is constant with the changes in the input. That is called law of constant returns. And from this point, if there is any change in the behavior of this output is like this. Means as increasing the input from this point to here, if you look at from this point, the increase in the input is changes in the input is high, but there is a returns are very less. So that is what we can say law of diminishing returns or decreasing returns. That's what we discuss here. Law of increasing returns, and then a constant returns from here to here, and then diminishing returns from this point to this point as there is increase in the inputs, as there is a change in the inputs. That's what the law of returns is. But most of the production systems generally it shows the sequence of increasing returns. Most of the production systems, if you take, it shows a sequence of increasing returns. First followed by the law of constant returns, and then by the law of diminishing returns. And is in this, the different phases, that is phase one and phase two and phase three, you keep taking. So first it goes with us increasing the returns, and after reaching this changes in the input from 3 to 5, then it leads to the constant return. So here, what are the causes of this increasing returns? So generally, in the beginning of any business, in the beginning of any business, both machinery and labor, which are called as factors of production, that machinery and labor would be working at less than the optimal conditions. So when both move towards optimality, when you're going for optimality, the output increases without much increase in the inputs, So the increasing returns are very much possible in this case. And also in the causes of constant returns, when the constant returns, what are the causes of these constant returns? When all the resources are nearing to the optimality, means optimum utilization of the resources, the rate of return is proportionate to the inputs only. So when it is reaching to the optimality, so the rate of returns will be proportionate to the input changes in the inputs. That is why during this period of constant returns, production just matches the inputs, so not much return will not be there. And the causes of diminishing returns, if you look at managerial efficiency, generally as the efficiency of the any manager usually decreases as the firms expand in size. Means if the organization grows, the efficiency of a manager will decreases. So greater the size of the organization, lesser will be the sense of the property, and as well as propriety, and as well as accountability, and as well as achievement. All will affect these output returns. And also another fact is responsible for diminishing is exhaustibility of the natural resources. Sometimes the resources may exhaust. For example, you are trying to double the labor and machinery in the coal mine, will not help you doubling the coal yield. Why? Because coal is a natural resource which can be exhaustible. So when you are trying to increase the labor and increase the machinery, which are called as inputs, scale of inputs, but the return on the what you are digging for the coal is become less, because the natural resources are might exhausted. Even though you are increasing in the input, but the return is going to be reduced. So diminishing returns. So these are the some of the causes of returns, that is in the increasing returns and the constant returns, as well as in the diminishing returns. Now we'll go with the interest and interest factors. You might have heard about this interest. We know that interest is nothing but you are going to pay the money for the money which you have borrowed from others. So it is nothing but the rent which are going to pay for the money which you have borrowed. So generally interest is the cost of using the capital. So when you try to use the capital amount, for the usage of the capital amount, the cost has to be bare. So that is nothing but interest. And also it represents the time value of money. Means the money has got a value as it ages or as it increasing in the time. So interest represents the growth of the capital per unit period. Because this will be added to the capital amount. The period may be the month or quarter or biannual or year also. You can take the interest periods, maybe monthly interest you can take, quarterly or biannually or yearly. So it depends on the time period, maybe changes. And rate of interest, generally it is expressed in the form of percentages. And it is there are two types of main rates of interest, we can say, which are commonly practiced. Probably might heard about these two words, which is simple interest and as well as compound interest. Under the compound interest, we will be having the different interest rates. One is the nominal interest rate, and then the effective interest rate, and then continuous compounding, These are the three different interest rates we can call it as under the compound interest. This concept of interest, has not changed any even or because it is using from the so many years. Not it's not started from the now. It is origin is long ago. In 2000 BCs only it has started this interest and all. So interest, say it is changed for a loan in the terms of, say for example, some of the it may be from 6% to it can vary from 66 to 40 or 30. It depends on the nation to nation. It will be keep changing. And for the personal loan, if you take for any loan you take, for that loan you will be having a different interest rates. So now we'll discuss these two main rates of interest individually. So simple interest is nothing but it is a computed only on the original sum, principal amount. That is, original sum is nothing but we can call it as the principal amount. Principal amount not on a prior interest and left in the account. Okay, so it is the computed only on the principal amount. Simple interest is only on the principal amount. Whereas the compound interest arises when the interest is added to the principal of a deposit or a loan. So you have a principal amount and you'll be calculate the interest, and this interest which are calculated will be added to the principal amount for the next year. For the next year calculation, we are going to add this interest to the previous principal. So so that from that moment the interest that has been added also ends interest. So you have, say for example, first year you have added the interest, for the principal amount. Then the next year when you calculate for the second year, so P plus I will be the principal amount. P plus I will be the principal amount. So this addition of interest to the principal is called as compounding. The addition of interest to the principal is called as compounding. So when I take the simple interest, so simple interest is quoted and the interest earned directly proportional to the capital involved, capital or principal involved in the loan, principal amount. So the formula for the simple interest probably might have PTR by 100 principal amount, time period, and as well as rate of interest. So here the terminologies I have just changed accordingly, that simple interest is equal to principal amount, N is the number of interest periods, and I is the rate of interest. I is the rate of interest. So here SI, or we can say simply I also, capital I is called as the simple interest, which is the interest earned on a particular principal amount for a particular time period. So I, simple interest is nothing but interest earned on a principal amount for a particular time period. That is called as simple interest. So simple interest is calculated by using the equation P into N into I. So what P stands for is principal amount. That is the amount which you have borrowed. Okay, the amount which you have borrowed or lent. And N is the number of interest periods, means for how many years you have taken, for how many years you have taken, or for how many months you have taken. That says the N. I stands for rate of interest. It can be per annum or per month, as well as per quarter, as well as per half yearly or biannually. So it can be, the rate of interest can be monthly, quarterly, half yearly, or annually. So that if it is a, generally the rate of interest will be taken per annum. So based on the rate of interest, the number of interest periods also to be, suppose if the rate of interest in months, then the number of interest periods also should be mentioned in the months, so that we can calculate the interest for the principal amount which is borrowed. That is the simple interest concept. Then coming to the, suppose if P is fixed value and the annual interest charged is constant, then the total amount borrowed requires to pay a lender, how much has to be paid at the end of say for example. So here I will show you. Yeah. So here I have taken a principal amount. Say for example 1000. Okay. I have taken a principal amount, say 1000. Okay. And that is for, say for example, for 2 years I have taken. Okay. For 2 years I have taken. And then the rate of interest, say for example 10%. Okay. So for this, the principal amount for this for the principal amount, that is rupees 1000 rupees for 2 years at a rate of 10%, then I need to calculate what is the simple interest. What is the simple interest? So simple interest is calculated, which you have told that P into I into N. Okay, N, capital N. So I can use 1000 into 2 years into 0.1. So 0.1, so it will be, I'll be getting 200 rupees is the interest. So 200 rupees has to be paid. Okay, 200 rupees has to be paid for at the end of 2 years. Means per year it is 100 rupees, per year it is to be 100 rupees likewise. So then what is the amount? What is the amount I have to pay at the end of 2 years? At the end of 2 years. So that is nothing but I can represent the amount I represent as F. That amount I represent this amount which I have to pay after this. So F is equal to P plus simple interest. Means P is 1000. Simple interest which I have calculated is 200. So I have to pay 1200 rupees. So we know that P plus simple interest is P into I into N. So I can write P into 1 plus I into N. 1 plus I into N. So this is the amount which has to be paid at the end of 2 years. So that is the equation which I have written here for the simple interest case. Now coming to the compound interest. So compound interest is, as we told, that the principal amount. Now see the example which I have taken here. In the same example, if we take, so this 1200 from third year, for the third year, say that will become as a principal. That will become as a principal. So here in this, actual principal amount is 1000. Actual principal amount is 1000, but here 1200 has become the principal amount from third year onwards. Means once again we need to calculate the rate of, I mean, how much is the interest, how much is the interest for this year, and then add the interest to the principal at the end of the third year, P plus I. Then this will become, this F will become the principal for the fourth year. That is, F will become principal for the fourth year. So that means that every year you need to calculate the interest. That interest is added to the principal, and then the principal will become the for the next year. Principal, it will become the for the next year. So likewise, that is what you can call as compounding. So if the borrower does not pay the interest earned at the end of each year, okay, at the end of each period, the interest amount is added to the principal amount for the future interest calculation. So the interest will be calculated and added to the principal amount, and then this will be calculated. So therefore, the interest, whatever you owed in the previous year, becomes the part of the total amount which you have taken for that particular year. This is what you can call it as compound interest. So it will be just keep adding. The interest will be added to the principal for the next calculations. That is what we can call it as compounding. That is what you can call it as compounding. So compound interest. So compounding amount is calculated by using this equation, that is F is equal to P into 1 plus I whole to the power of N, where the P stands for principal amount, I is the rate of interest, N is the time periods, number of interest periods or number of interest periods. So this is about the compound interest. So now, so here the problems I'm not discussing on the simple interest and compound interest, which I have studied on in the lower classes. So that's why I'm not touching upon. Anyhow, one or two problems will do it on this issue. Okay, right. So coming to the very important topic is cash flow diagrams. Cash flow diagrams, we can call it as cash flow diagrams. What is a cash flow? So if you take any organization, so every organization have their own engineering projects. They have their own engineering projects, which are generally have economic consequences that occur over an extended period of time. So if you look at this example, if an expensive piece of machinery is installed in a particular organization and which is bought on credit, the simple process of paying for it may take several years. That is how we are going to pay. Is it annual? You are going to pay and that and all we can call it as how you can take the cash flows for that particular machine. Then the resulting favorable consequences may last as long as the equipment perform its useful function. Means this resulting cash flows, that is paying amount for the bank, so it will be carried out as long as it is under the usage, as long as it's under the usage. If it becomes obsolete, then it will be made scrap. This will be made scrap. Next, each project is described as cash receipts or disbursements or expenses at different points in the time period. In the different points in the time period. So here, each project is buying a machinery is one. Say for example, buying a machine. So is one project. So here the cash receipts and the disbursements, which are at different points, means. So once you start with the machine, so the machine is keep running. So at the end of a year, you might have incurred the maintenance cost. You have to pay the what you call EMI for that particular machine. So you might have got the some labor cost and all those for that particular machine. So these are all called cash receipts and as well as disbursement on a particular project at a different particular point of times. So categories of cash flows. So when you say what are the cash flows we have? So first cost. So first cost is nothing but it is the amount which you have given to buy that particular machine. Okay, to buy and as well as install. To buy as well as installation cost. So buying and installation cost will become as a first cost. So expense to build or to buy and install, that is called as first cost. That is called as first cost. And operations and maintenance, as we told that the machine as once installed, so it has to undergo the maintenance. It has to undergoes the maintenance. That is called O&M, operations and maintenance. So this is annual expenses. This is annual expenses such as electricity and labor and minor repairs on the machines. All will come under this maintenance, operations and maintenance. So this is one of the cash flow. So first cost is one cash flow. Operations and maintenance is one cash flow. Salvage value is one cash flow. That is, salvage value is nothing but it is a receipt at project termination. Means once it is gone, it has given it is useful years. Means that service is lost. I mean, say for example, one machine is service is say for example 10 years. Life of the machine is 10 years. After 10 years, the amount which you get on that particular machine is called as salvage value. When you sell it at the end of the useful years, or at the end of the life of the machine, the amount which you gain, that is called as salvage value. So receipt at project termination for sale or a transfer of the equipment, that is called as salvage cost or salvage value. And another cash flow which you can get is revenues. Means by selling of the products, you may get some revenue at the end of the first year, at the end of the second year, or by the giving services. By giving the services, then you can get the money also. So revenues are nothing but which you get the money, that is called as receipts. Annual receipts due to the sale of products or services, that is revenue. And overall is also one of the cash flow, which is a major capital expenditure that occurs during the asset life. So what capital expenditure is going to occur during this asset life is called as overall. So these are the different cash flows. Which you can see in any particular organizations. Okay, for any projects. Now coming to the cash flow diagram. So what is we have talked about what is the cash flows. So what are the categories of cash flows? So then how to represent in the form of diagram? Is called as cash flow diagram. So if you look at a cash flow diagram, is nothing but it is a pictorial representation. So the cost and the benefits for any projects over a particular period of time are summarized on a cash flow diagram. It means that what are the costs you are incurred for a particular machine or a particular project, and what are the benefits or profits you are going to get for that particular project over a particular time period. That is what you can call as cash flow diagram. So these things, if you represent on a diagrammatically or graphically, then it is called as cash flow diagram. Specifically, cash flow diagram illustrates the size, sign, and timing of individual cash flows. Cash flows, we are just talked about the different categories of cash flows. So how, I mean, at what amount it is coming? Cash inflows and cash outflows. If you take any organization, there will be two things. One is the cash inflow and cash outflow. Cash inflow is nothing but receipts. Cash outflow is nothing but expenditures or disbursements. Expenditure or disbursements. So here, those cash inflows and cash outflows for a particular project has to be represented in the form of graphical. So that is what you can call it as cash flow diagram. So cash flow diagram is created by drawing a segmented time-based horizontal line first, then divided into appropriate time unit. So once you understand this cash flow diagram, the entire almost 3 modules is depends on this cash flow diagram only. So what is the cash flow diagram and how it will be represented, how it can be drawn? So it is first we need to draw a horizontal line and then dividing this into an appropriate time unit. And each time when there is a cash flow, you need to represent a vertical arrow. You need to represent a vertical arrow showing downward or upward. So depending on the whether it is a cost means which is a cash outflow, then we can say it is up, I mean down. It is down. So vertical arrow is added pointing down for costs and up for the revenues, which is coming a cash inflows. Cash inflows as called as which can be shown pointing upward, pointing upward. So that cash flows are drawn to a relative scale and drawn to the relative scale. So in a simple terminology, I mean simple diagram I'll represent here. So what is talking about is a cash flow diagram. So a cash flow. So when I'm talking about cash flow, so generally any organization there will be a cash inflows, which is in the form of revenues, and there will be a cash outflow also, right? There will be a cash outflow also, which is in the form of expenditure, expenditures or cost, whatever it is, or any disbursements of bills, okay, disbursements. All this can called as cash outflow. So here the representation of cash flow diagram. The representation of cash flow diagram is, so first we need to draw a horizontal line. Draw horizontal line. See here, this is the horizontal line which I have drawn. Okay, this is what you can say. Draw horizontal line. So the horizontal line is nothing but this represents. So this horizontal line represents the time scale. With time progressing from left to means, say for example, this is 0 and uniformly 1, then say 2, then say 3, likewise we are going to represent say 5 and so on. We can say I can give a breakage at the end of nth year, so this is in the form of years, so first year, at the end of first year, at the end of second year, at the end of third year, at the end of fourth year, like that. So till the n is nothing but useful life, or life, I can say useful life of project, or life of project, you can say in the simple term, life of project. So for any project or for any mission or for any equipment, there will be a life, service life, you can call it as service life. Okay, so that service life is nothing but n. So here he has told that it's a line which is need to be represent a horizontal line. So if you look at this, a segmented time based horizontal line divided into appropriate time units. So I have divided into appropriate time units like 0, 1, 2, 3, 4, 5 years. Then is what is talking about? He is talking about each time when there is a cash flow, a vertical arrow upwards for cost, downward for cost, upward for revenue. So this shows, say for example, if I mention, say at this particular point, I have mentioned like this. Means this is cash outflow. This is cash outflow. So this horizontal line, if you take, it is going outside of this horizontal line, means going out means outflow, which is represented for cost, which is represented for cost. Revenue. So revenue is not, say for example, at this point, at the end of third year, I'm going to generate the some amount, say Y, some amount Y. So this is the cash inflow. It is coming inside. That is, which you can say inflow, cash inflow. So returns and as well as expenditure. So returns, these are called as returns. So we can take it as this is returns. These are returns, and these are expenditure or cost. These are cost. These are revenue, or they have different names. Revenue, as well as this I can say cost. Revenue means returns or profit, whatever you get in terms of cash inflow. Cash flows talking about, he is talking about cash flows. If there is cash flow, when there is a cash flow, a vertical arrow pointing down is represented for cost, means if there is expenditure at a particular point of time, that has to be shown as a downward arrow. Say for example, here this shows, say for example, maintenance cost. Say maintenance cost I have. So this has to be shown as a downward, because at this particular point of time I have a maintenance, so that will be shown as downward. Okay, that will be shown as downward, right? Next, yeah. So that is what you can say cash flow diagram. So how to draw a cash flow diagram, that we have shown. See here in a cash flow diagram, the end of the period T is the same as the beginning of period T plus 1. Means what is talking about, this first point is, see this diagram. So the end of the time period second year, this is the end of the second year, and also this point I'm talking about, this point here. So this point says end of the second year and the beginning of the third year. So this point is also beginning of the third year. So third year begins from here, right? So end of the second year and the beginning of the third year, both are same. That's what he's talking about here. Okay. So end of the in a cash flow diagram, the end of the period T is the same as the beginning of period. That's what it's talking. And beginning of period cash flows. So beginning of period of cash flows are might be rent, or might be lease, or might be insurance payments, or anything. So beginning of any cash period. So here it may represent, say for example, here my cash outflow is there. So I can show here there is a say for example, I'm paying the insurance. I'm paying the insurance at the end of second year, or I'm paying the some rent or something, some rent or on the machine purchase for 3 years. So rent is paid like this. So these are all cash. Any particular year, if you are going to show any cash flow, that might be either rent or revenue or cash inflows or cash outflows. So beginning of the period cash flows are rent, lease, and end of the period cash flows are maintenance. So at the end of the year, we are going to give the maintenance and all those. So at the end of first year, at the end of the second year, at the end of the third year, like that. Okay. So salvages and revenues all will come under the end of period cash flows. The choice of the time is arbitrary. Of course, it can be taken for the time when a project is analyzed, when a funding is approved, or when construction is begins. That will be taken as time 0, started from time 0. And 1% cash outflows will be taken as if it is represented as a outflows as represented as a negative, then inflow will become as positive. So it is better to show two or more the cash flows occurring in the same year individually, so that there is a clear connection from the problem statement to each cash flow diagram. So here, if I draw here this cash flow diagram, so now I represent, say I have a horizontal line. Say for example, at 0 I have invested some amount in buying a machine, that is invested amount, and on this amount, on this, say for example 1, 2, 3 and 4, say for example 5 and say 6 years. So you have taken or borrowed money from the bank So then expecting or you are given some amount, some money from you and to a particular person, and you are expecting at the end of 6 year, at the end of 6 year, some future amount. So at the end of the year, whatever your amount you get, that is called as future amount. At the beginning of the year, with the amount which is called as present amount, or principal amount, or present, we can say it is a present amount. We can say present amount which you have given to a particular person, and this is the future amount which you are going to get at the end of 6th year. Future amount which you are going to get at the end of year, and this is the time period which you can say this is the time period. So, and also represents I rate of percent on this. So you need to represent the what amount you have borrowed and at what rate of interest, and for how many time periods, and for that time periods how much amount I'm going to get, that shows complete cash flow diagram. That shows a complete arrows here signifies the cash flows. This arrows means this is a cash outflow. Say this says cash inflow or revenue, or say for example revenue is or receipts. Here it is a it is a cost, or expenditure, and so on. Okay. Then cash flow diagram is dependent on the point of view how you are going to looking at. Say here, suppose here is a lender or borrower, means who takes the money. Say from lender's point of view it is different, and from borrower's point of view it is different. So you need to specify for whom you are drawing the cash flow diagram. So if this is say for example lender point of view. Okay, this is a lender point of view. Okay, means who gives money to you. Lender point of view means who gives the money to you. So he lost the money at the zero because he is a lender who gives you money. He lost the money at time zero with the principal amount of C. Say he has given a loan of 10,000 to a person B. So this is A's cash flow diagram. A's cash flow diagram, it represents his cash outflow of 10,000 rupees because he is giving for B, is giving to B. So what is the B's cash flow diagram for the same? Then B is getting amount of 10,000 rupees. So for him it is a inflow. B is taking money from A. So for A it will be going out, and for B it is coming as coming in. So cash inflow for him. But at the end of the 6th year, for B it will be cash outflow because he need to pay the amount. F at the end of 6th year. At the end of 6th year, 1, 2, 3, 4, and 5, 6. See the difference between this and this. So this is A's point of view, who have given the money to the B. A is giving money to the B. So A, in the point of view A, he is giving the money means he is losing the 10,000 rupees. So it is a cash outflow for him. And he can expect the money at the end of 6th year. That is what you can call as future amount. So if that is for cash inflow for him at the end of 6 years for at the rate of I, with the rate of interest I. Similarly, for the B's point of view, he has gained the amount of amount of 10,000 at the point 0, and he has to pay. That is cash inflow for him, and he has to pay at the end of the C. He has to payment. This is called payment for B. This is payment for B, and this is the receipt for A. This is the receipt for A. So A and B, that is the difference between the cash flow diagram with respect to the A and as well as with respect to B, with respect to A and with respect to B. So is it clear now? So with this cash flow diagram concept, I'm going to stop now. Now we'll go to the PPT. So this drawing a cash flow diagram is very much essential in this economic analysis. So first is draw the horizontal line. In this, after drawing the horizontal lines, you need to represent the timeline. That is from starting from 0 to the service life till the service life, and you need to represent the cash flows, cash inflows as well as cash outflows for the any event or any project. then the one person's cash flow is, if you represent it as a positive, then the other will become as a negative. So that is what we discussed. And here the interest formulas. Next topic is interest formulas. So once you understand this cash flow diagram, then the interest formulas are very important, because this module is completely numericals on this interest formulas only. So all seven types of problems will be there. One is for single cash flows as well as for uniform series of cash flows if we have. So single payment compound amount, single payment present worth, and uniform series compound amount, uniform series present worth, equal payment series sinking fund, equal payment series annual equivalent amount, arithmetic gradient conversion factor. All this we can call it as interest formulas. So for each one, we are going to discuss one by one. So if you take this, what you call a single payment compound amount, single payment compound amount is nothing but which you need to pay at the end of a particular year, So single payment in the sense which you need to find, which you need to give. Say that's what we discussed in the cash flow diagram. See here. Yeah. The objective is here. The objective in the case of single payment, first one, single payment compound amount. So main objective in this is to find, means the single payment, to find the single future sum or amount which you need to pay, single future amount you payment. It is a single future sum you are going to get, that amount to pay, paid by B, or we can say a single future amount for initial payment made by you. Initial payment made by you. Initial payment, which I can say present amount, which you can say initial payment means which is at t is equal to 0. Initial payment is nothing but t is equal to 0. That is called as present amount. That present amount, how much is the single future amount we are going to get for the initial payment you have made for B. So that is, you are given a 10,000 rupees to B. So what is the future amount I am going to get for so and so interest rate and for so many years? That is what we can say single payment compound amount. So the cash flow diagram for this is going to be, that is, at the beginning of 0 time you lost the money, and say this is for n time periods, what is the future amount you are going to get. So this is the lender point of view. I have drawn lender point of view, because lender is going to lose the money at time 0 and he gains the money at time n. So that is why I have mentioned this is in a, what you call lender point of view. Is it clear? Right. So next we'll go with one problem so that you can understand better on this. Right. So in this, say for example, a future amount, say for example, you have taken a person deposits a sum of 10,000 rupees in a bank at a nominal rate of 12% for 10 years. Okay. So if I have taken a person, okay, a future, we will take one more way. Future amount, F is equivalent to 1,500. Okay. So now when 8 years time periods amount at the annual interest rate of 12%, what will be the future sum? What will be the future sum? What will be the future sum? So here, okay, so the present amount is equivalent to 1500. So the present amount is 1500. Is asking for n is 8 years and then I is at rate of 12%. So we have a future amount equation, that is f is equal to p into, of course here the compounding annually. Okay, so compounding annually. Okay, so this is annual. Okay, annual rate of interest. Annual rate of interest. So that is 1 plus I whole to the power of n. So we have the equation, that is 1500, 1 plus I is 0.12, whole to the power of n is 8 years. So if I calculate this equation, roughly around get 3000 something. So 3000 plus I'm going to get. Okay, so this is how we can calculate the future amount at a particular single payment made at initially. Single payment made initially, that is what we can call it as single payment compound amount, single payment and compound amount. So you need to draw the cash flow. So see here, the very important thing is, first is write the given data. First is write the given data. Based on the given data, draw the cash flow diagram. Draw the cash flow diagram. After drawing the cash flow diagram, then use the interest formula. Which interest formula is going to be used, and then substitute the values, get the result. So these five are very important. Given that very important is drawing a CFD diagram. Of course, given data, anyhow, just take the values from the problem and then you can write. And interest formula is also very important. Usage of interest formula, and which interest formula, because out of seven interest formula, which interest formula is going to be used? Is it a single payment compound amount, or is a single payment present worth, or it will be a uniform series of compound amounts, or it will be a uniform series of present worth? So depending on which factor, which interest factor I have to use, that you need to know in this third point. So then fourth is substitution of this values in this equation, and as well as finally result. So means you need to how much the amount is going to be paid at the end of say 8 years, is that statement, conclusion statement or final statement to be written. Final statement to be written. So why I am telling is because it takes very less time to complete a problem. Hardly it takes 3 to 5 minutes to complete one problem. So because of the lesser time, so better you represent or present all this information for a particular problem, so that it will be easy to get the full marks for the problem. So given data, draw the cash flow diagram, and uses of interest formula. Then after that, writing a substitution. After a substitution, you'll get some result. Then based on the result, you write the statement. So these things has to be present. So then you'll get a full marks. Simply just writing the equation and then giving a one line, so you will not get the marks. So it should be very clear in all these aspects. Okay. So with this, I stop today.